Hey, what's up, everybody? This is Mr. Skits, and welcome to another Skits Tut. Now, if you've been watching the series, then I promised you that this video was gonna be fun-filled and exciting, and this is gonna be the best experience that you've seen so far. I'm gonna teach you today about artificial intelligence for your enemy so it can actually think a little bit. It's gonna be basic, but it's still 500 lines of code, and I'm gonna make it a little easy. I'm gonna post it in a forum, and you'll be able to copy all the code so you don't have to worry about typing it all out. But it's better if you do so you get the feel for it. But anyway, we're also going to be talking about line casting, which is a form of raycast, and it's very efficient for what we're doing. So if you can look at this enemy that I had created right here, you see all these dots. These are just gizmos that I had put on there, and I'll get into that in a minute. But for this tutorial, you are going to want to create a bullet for your enemy, and you do want to have your enemy created. And for your bullet, you basically, I didn't even put a tag on it, but you will want to tag it something later on. We'll get to that in the next video. You're going to want to put a rigid body 2D component on it, and just like the player bullet we did, gravity scale set to 0, and our rotation Z is locked. I put a circle collider on mine, as you can see right here, and we made it an is trigger, so make sure that's checked. And I added the enemy bullet script component. And the way you add the components, you should know this, but you just click the add component, and you'd go to physics 2D to get the rigid body and the colliders. You want to make sure you're using the rigid body 2D and 2D physics. And you can just click the script after you have created your enemy bullet 01, and you can add that to your bullet. Once you've got the code and everything is good to go, you're just going to drag your bullet into the project, and it'll turn it into a prefab, and then you can delete it from your hierarchy. The next script you're going to want to do is the enemy move. You want enemy detection and player detection. So first we're going to finish the enemy bullet, and I'll go over with you real quick. It's pretty simple. The only thing that we need to do is an on trigger enter 2D, and if it hits a wall, we're going to destroy it. If it hits the player, we're going to destroy it. So that's all you really need to know about this. In the next video, we're going to be dealing with health points and stuff. This is going to be a little bit different for the player. It's going to damage them, and I don't want to get too far ahead. We got a lot to cover in this video here. So I guess I should show you before we go any further how I made the enemy. Basically, I created an empty game object just by clicking the create empty, and I reset its transform to where it was at the 0, 0, 0, 0. And on this empty, I added the rigid body. Once again, the gravity set to 0, and the Z axis is going to be frozen. I put on the enemy 01 move script on it, and we'll get to what these are in just a minute. So originally the enemy, as you can see, he's facing upwards now. He was facing downwards, and I didn't really want that. So what I did is I had right clicked on the enemy, and I created another empty. I named it enemy rotation controller. Then I drug my enemy into the scene view over here, and I put a polygon collider on them, but you could put a circle, a box, any kind of collider that you want. And that's basically all we have. So notice that he is not an is trigger. He's actually a solid collider, so he won't go through things. So make sure this is not checked. So anyway, once I put this on him and he was in the scene, he's going to be underneath enemy. I drug him into here. Actually, hold on, before you do that, you want to set your rotation to whatever direction you want your enemy to face. In this instance, this is the way that I wanted it. Now when you drag your enemy object into the enemy rotation controller, his rotation is going to be like -90 or -180 or something like that. You're going to want to click here and you're going to want to set that back to 0, and he'll be facing the direction that you want. And I also right clicked again, created another empty, and I named it bullet spawn. And that's this red dot. Now if you look right here are where the gizmos are, and you can see that I just clicked this, and that's what these dots are. They're just gizmos. They're not viewable in the game scene. You can make it, but there's no sense in me talking about that part right now, so I'll just keep it moving. But anyway, this is where the bullets are going to spawn from, right here. Now I made it a child of the actual enemy object, because any way he rotates, we want that bullet spawn to rotate with it, so that he's always firing in front of the enemy. Now I right clicked, I created another empty and named it detection holder. I right clicked and I made another empty called player detection, and then I duplicated it by clicking on it, hit Control and D, and then I named it wall and enemy detection. Now these are actually what's going to hold the script. So the player detection holds the player detection. The wall and enemy detection is going to have our enemy detection script on it. Now inside of the player detection, we're going to have an origin point and an end point. So if I highlight, you can see that the end point is right here. So the player detection, I basically created a radar to where it's going to spin around, and if the player is in that range when it's spinning around, it'll lock onto him, and then the enemy will instantly face the player. So this is really what's going to catch the player right here, and it's going to lock onto him. So when you're doing line casting, you always need an origin and you need an end point. So that's all there is to the player detection. Now the wall and enemy is a little more complex because it's the same concept, but we need to be able to detect down. So if you look, we have the origin and the end point here. So this is detecting down. And then I just duplicated it. Once you created because these are all just empties. So you're going to create an enemy the same way you always do. Create the empty, origin and endpoint, name it down. Now you're going to want to set your points up downwards. Doesn't really matter. I could have put them up here. I just thought that down would look better here, right from right here, left from right here, and then up from right up here. Once you set your down up, the origin and then the end point, you can just Control D and duplicate it, and then you can make that the right. You duplicate that, you make it the left, and you duplicate that and you make it the up. So now you only had to do it one time, you achieve the same thing, but each time that you duplicate it, you're just going to want to set your origin up where you want, and then your end point up, so that they're facing in the proper directions that they need to be facing. That's pretty much it for the enemy. I'm not going to do it in this one, but the enemy will become a prefab, and then in the next one we'll make it where it spawns, and then the enemy will, a bunch of enemies will spawn, and it's like a non-stop marathon killer. You know what I'm saying? It'll be pretty cool. But for now, I'm pretty sure that's covered everything on there. Except for, we're going to go over the script now. We'll do player detection first. So we needed the transform of the origin, the end, and we need to know where the player is at all times so we can detect them and make the player look at them. Now, I told you about how the endpoint is going to spin around and detect a player. I called it a radar, so that's the speed in which it's going to go. It's a float. Then a bool. So in other words, since it's public, you'll be able to see it in the inspector. It'll turn true whenever the player is detected. And this works. It's awesome. It's cool. Now, we need to send the player is detected information to another script. So it's a static bool, which means it can be accessed from any other script and it can be altered also. So you got to be careful when you do static variables. So anyway, that's what this is going to do. Now, this is something that you probably haven't seen. It might seem kind of confusing, but I'm about to go over this with you. This is bit masking, excuse me. So this is basically saying the layer number 8, if the player, because this is a layer mask right here is what we're doing. So it's going to return 1, which is true. 0 would be false. So if it turns out to be layer number 8, it's going to return true to this boolean here. And I'll show you how that works. Basically, on your enemy object, notice that I tagged it enemy1, and then there's a layer. So this is your layer, and this is how we're going to determine, like on the player, for example, we have a player layer. So we can detect it. Now when you click on it, you can see that the player is the level 8. Number 8. Enemy is number 9. Wall is number 10. So basically, when we're bit masking, we're actually grabbing, okay, if the layer is number 8, we're going to return true. And that's pretty much all there is to this. It's pretty simple. Of course, we want to know what the enemy rigid body is. It's pretty typical for any game object that we're moving with physics. The vector 3 to face player, it's going to be a little bit more complex, but I'll show you how we use this. Just know we need to capture all the positions. We're going to immediately get the component in the parent, the rigid body 2D. And the reason that we have to do it this way is because with the enemy, we have it here. So we need to get the parents, because this is where the rigid body is, right here. And this is the parent. This is the child, and this is the grandchild. So we're just going after the parent. We're getting the rigid body. Now we're going to start off player detected is false by default, so that when we start spawning our enemies, they're automatically going to start off not detecting the player until the radar touches it, and then the player will be detected. And this is a good little setup. We're going to call a function that we're going to design called player detector, and it's going to run every single frame. If player detected is false, we're going to make sure that the radar is ticking. If not, then we're going to play the player is detected function, and the radar is not going to be moving around anymore. And that's how we lock onto the player. So what is the player detector, which is right here? It's always running. Well, the first line we need to know is what is player detected. Well, we're going to call a physics 2D line cast. And if you look, you can see that inside of the line cast, there's a vector 2 start, a vector 2 end, and an integer for LayerMask. So if you notice, we have our origin position, our end position, and we have the player layer right here, which is our bit mask that we did right here. So that's what's actually in there. So we're actually looking for the player, which is that number 8 layer, and it'll return true, and the player will be detected. Now you can't see rays and raycast, line cast, so in order to be able to do that, we're going to do a debug draw line, and it works to whereas if you look, you need a start point, an end point, and then you can put a color in there. So I did that, the origin and the end, and I just colored it red, but you can put whatever color you want to work for you. Now the radar, it's going to be the end point is going to rotate around the origin of this, and then we're going to look vector 3 forward, which is going to make it always move counterclockwise, I believe, or is it clockwise? I can't remember which one, but either way. Then we're going to use the radar speed times time.delta time, and that's kind of a smooth control, and it tells what speed it's going to be rotating at. So you can just adjust radar speed inside your inspector until you find the right speed that works for you. Player is detected equals false, because he's not detected until he is detected. So if the radar is spinning, then the player is not detected. So that's why I put that there. Created a function player's position. Now this is the face player, the vector 3 we created that I told you I'd explain. This is what's going to make the enemy face the player. We need to know what the player's position is. We need to subtract it from the enemy's rigid body's transform, and this is the get the child and get the grandchild's position. So it's basically saying from the enemy to the player, we need to subtract that. And I had a serious problem. I had a hard time figuring this code out, so I had to look out to the Unity community and the forums. And I have a buddy there named, I think it's Vakabaka or something like that, Vakbata or Vakbaka. Anyway, I just want to say special shout out to you for helping me out with this code, man. I really truly appreciate it. I was stumped for like a week on this, and it was chaos. So thank you very much, and y'all need to thank him as well, because this is some pretty good code right here. Way better than the crap I had. So anyway, this is going to be the enemy's rigid body, and we're going for the grandchild, and since I'm facing up, it's going to be dot up equals negative. The enemy look at the player. Now we have players detected, and if it's true, then we're going to put player is detected as true, and then we want the end position of the ray to be the exact position of the player, and that's what makes the endpoint stick to him, and that's what keeps the enemy looking at him. And that's how we call the player's position right here. Alright, now we're going to get into the enemy detection. It's going to be the origin points and end points of up, down, left, and right. So we need the transforms of all those. We need the booleans for detected down, detected left, detected right, and detected up. Then we need to be able to pass this information down, left, right, and up. So is the path open? We need to pass it to the enemy movement so that the enemy can make a wise decision while he's moving. So the wall layer is the same thing. If you remember, number 10 was the wall layer. So if that returns, if it's a wall, it's going to return as true. So that way our rays will detect the wall. We're always calling the wall detector in the update. This is the same principle as what I just went over in the other one, so I don't need to repeat that, hopefully. but you just want to make sure that there's one ray cast for the down, to the left, to the right, and to the up, and you want to draw a line to each one of those so that it's going from the origin point to the end point on each one. I painted them all green so that you can see it. Now note that you can only see your ray cast when you push play. You will not see the rays until you push play and actually play your game. So to check results, we're going to call that in the wall detector, which gets called every single frame. It's going to check the results. If the wall detected down is true, path open down is false. And it's the same thing. So either it's either going to be open or it's going to be closed. And that's the same thing for each one of these. So this is what's telling you if it's detecting a wall or not. And that's all there is to that. Oh yeah, here comes the fun part. I created a weapon field for the bullet and the bullet spawn, the enemy rigid body, the enemy speed, the bullet speed, the shoot timer, which is going to be the fire rate in which the enemy can shoot so it doesn't non-stop fire. Then we had to declare a move direction so that we can determine which way that the enemy is going to move. That's going to be determined there below. The current direction, I started to do this so that we can make sure he never backtracks. This is how you would do it. I think I used it one time and just decided that the code was getting long enough, so we'll just leave it as is. And if you want to do this, you can do it. But trust me, there's a lot to artificial intelligence coding, so you'll see. Now, we have another boolean, can change. That's pretty much for can change direction or something like that. Can fire, that's determining whether or not he can fire. If he's ready to fire, then he has to go through the shoot timer and then he can fire, so it's like a little system. And we needed to know the vector 2 for the move direction. Now upon start, you have to get the rigid body. Move direction is going to be a random range, so if you put 1 through 4, I believe 4 would be impossible to get, so you want to do 1 to 5 from my understanding. So if the move direction is less than 1, so if we get 0 for some reason, or if it's greater than 4, then we'll just check while it's less than or it's greater than. We will just keep flipping until we get something in between 1 and 4 basically. And once that's done, it's going to go ahead and we're going to set can change to true. So this allows the enemy to pick a random direction when true. Can fire, enemy can only fire if this is true, and ready to fire when true. It will set can fire true to properly set the fire rate. And that's basically what that does. Alright, this is how we're gonna detect. If player detection, player is detected equals false, we want the movement handler to work. Ready to fire will automatically be set to false, and the shoot timer will automatically be reset to 1 so that it's full. If it's true, then we want the enemy to stop moving. And we'll get to that way down below. So if ready to fire is true, we want the shoot timer to decrement by time.delta time, which is just going to be, from 1 to 0. And if shoot timer is greater than 0 and can fire is true, we're going to start the code routine fire rate, which is below, way below at the bottom. If shoot timer is less than 1, then we want to go ahead, or less than -1, excuse me. We want the shoot timer to go back to 1. So we're basically resetting our clock, and that's what's going to keep the firing steady and smooth. The fixed update, this is no different than how we did the player movement. This is just the enemy version of it. Now the change direction, this is where it's going to get complex. This is actually the computer thinking and making a decision. It's going to determine which path. So if there's no walls detected, everything's true. So they're all paths are open. Then it's just going to choose one of these numbers, and once again we just make sure it's not 0 or above 4. If it does, it'll just go ahead and pick another one until it does. But it can move in any direction. So this one here, it can't move right. And this is what the code looks like for that. I don't need to go over it because it's the same thing. You just got to say if movedir equals 3, because 3 is false. That would be moving right. So movedir cannot equal 3. It'll just keep going until it doesn't get 3 less than 0, higher than 5. Higher than 4. Cannot move left or right. It's pretty much the same code over and over, so you can see what's going on. This is for if he can only move upwards, then movedir is going to be set hard-coded into the 4 because that's the only direction he can move in. If he can only move up or right, this is the line. This is the else if, so it's basically just checking what's open, and the first one of these that returns true, that's the one it's going to run. So if he can move left, right, or up, this is the code to make that work. If he can only move left or up, this is the code for that. If he cannot move left, this is the code for that. If he can move in any direction except for up, this is how that is achieved. If he cannot move right or up, this is how that is achieved. Cannot move left or up. Can only move downwards. Can only move left. Can only move right. And if we forgot anything, we're just going to go ahead and make them move up by default. So if he runs into a wall after that, then he'll just pick another number, and that's the way I have it set up basically. So this is how they're actually moving, is the same way we had to access the grandchild, and we just spin them in a direction. So move left, move right, move up, move down, and when he needs to stop moving, this is what will happen. And since stop moving is the function that's being called whenever players detected is true, we need to be able to make sure that the shoot timer is greater than or equal to 1. If this is true, then ready to fire is true, and can fire is true. So every time it'll reset, every time it runs, and it works good. So to start shooting, we're going to do the same thing as with the player bullet. We design a game object. We instantiate the eBull at the eBull spawn position, and we want it to have the same rotation. Now we want a rigid body, and it's going to be the eBull's get component. So we're just going to get the eBull's component, and we're going to put it into this variable. Now the rigid body, we're going to add force to it. It's the same basic principle we did for the player bullet, I already said. And this was a fail-safe. You really won't need that unless you don't have any walls or anything you can collide with. This is just to make sure that it doesn't go on forever eating into your memory. The movement handler is if move direction equals 1, then we'd want to check to make sure that down is open, and then we'll call the move down. Else, if move down is not, if path open for the down is not true, we'll change his direction. And that's basically what we do for 2, for 3, for 4, and if can change equals true, then we want to start the code routine for random movement. And this is how the player is randomly moving right here. This is the code routine that we're running. Can change will turn into false, so that this will only run one time. If you don't do this, then the IE enumerator will run it every frame non-stop. So we created a timer between a half a second and 2.5 seconds, so he'll randomly move for a random amount of time, and this is the timer that we wait for. So it's just gonna, every time it comes in here, it's gonna give a new value to timer. It's gonna put it here. It's gonna call the change direction. It's gonna wait for another half a second, and then can change is true again, and then this code will just keep running. The fire rate, we set it to false. Fire rate is basically the same concept as the timer. It's a fire rate timer. So it's going to start shooting, it's going to wait, and then it's going to set it back true again. And if the enemy runs into a wall, then we're going to change its direction. So even if he hits a wall, he's going to say, oh, I just hit the wall, and he's going to turn around and do something else. So it's kind of a fail-safe, because with random movement, he's not going to stop moving until this time is up. So even if he detects a wall, he's not just going to stop unless you code him to do it. I didn't do that. So with that said, that's pretty much how this works. Like I said, I'm going to post these codes in a forum, and I will put the link down below. That's showing a lot of love, so please, if you liked it, like and subscribe to this video. I appreciate it and hope you enjoyed. Tune in next time where we will design some health bars, including bars that'll be floating right above the players' heads. I'll show you how all that works. Thanks a lot. Tune in next time.